Hi, this video is here to help you work out the area of a rectangle. The area of a shape is the amount of space within the perimeter of a 2D shape. It is measured in square units such as square centimetres. We write square centimetres using this notation. Let's start by finding the area of this rectangle. Because it's drawn on a centimetre square grid, we can easily work out the area by counting the squares inside the shape. The area of this rectangle is 15 centimetres squared. If we put a counter in each of the squares, we can see that there are 3 rows and 5 columns of counters in the array. So instead of counting the squares, we could have calculated the area by multiplying 5 by 3. To calculate the area of any rectangle, you can multiply the length by the width. Let's apply this learning to the next rectangle. This rectangle has a length of 12 centimetres and a width of 6 centimetres. Using the formula, we can calculate the area of the rectangle is 12 multiplied by 6, which equals 72. Because the lengths are centimetres, the unit we use is square centimetres. The area of this rectangle is 72 centimetres squared. Now it's your turn. Use the formula to work out the area of each of these rectangles. And here are the answers. Well done if you got them all correct. We can also use a given area to calculate an unknown length or width. If the area of this rectangle is 72 centimetres squared and the length of the rectangle is 9 centimetres, we can work backwards through the formula using the inverse to find the width. 72 divided by 9 is 8, so the width of the rectangle is 8 centimetres. Now it's over to you. Use the information you've been given to work out the unknown measurements on each of these rectangles. Here are the answers. How did you get on? For C, which you'll notice is a square, you needed to use your times table knowledge to work out what number is multiplied by itself to make 81. Well done if you answered all of those correctly. Let's move on to the challenge. Holly needs a rectangular enclosure for her rabbit that is 20 metres squared. She is making the enclosure using fence panels that are each 1 metre long. The length must be longer than the width. What could the length and width of the enclosure be? Find every possibility. To solve this problem, you needed to work out what numbers could be multiplied together to make 20. Remember, these are called the factors of 20. Here are all the possible answers. I hope this video helps you understand how to work out the area of rectangles. If you're looking for more maths help, then we've got lots more of these videos on the Twinkl website, so go and check them out. Hi, this video is here to help you calculate the area of compound shapes. A compound shape is a shape that's made up of 2 or more different shapes. We're going to be looking at shapes that are made up of 2 or more rectangles. Before we get started, let's remind ourselves of the formula that we use to calculate the area of a rectangle. If you need more help with this, you could watch our Area of Rectangles video here. The area of a rectangle can be calculated by multiplying its length by its width. Area is measured in square units such as centimetres squared, which is written like this. Let's take a look at this shape. To calculate its area, we can divide it into smaller rectangles. There are different ways that we can do this, as you can see, but they will all give us the same answer. Sometimes we can choose how to divide a shape based on the information we've been given. Let's use the first option. We have divided this shape into 2 rectangles, which we'll call A and B. Now we need to calculate the area of A and B separately, before adding them together to find the total area of our shape. Rectangle A has a length of 12 centimetres and a width of 8 centimetres. So its area is 12 multiplied by 8, which is 96 centimetres squared. Rectangle B has a length of 6 centimetres and a width of 6 centimetres. It is actually a square, so its area is 6 multiplied by 6, which is 36 centimetres squared. 96 add 36 equals 132, making the total area of our shape 132 centimetres squared. Now it's your turn. Use this method to calculate the area of this shape. Pause here until you're ready to check your answer. Here you can see one way that you could have calculated the answer, which is 162 centimetres squared. Sometimes you might need to calculate the length of a missing side before you can calculate the area. If you need more help working out missing sides, why not take a look at our video, Perimeter of Rectilinear Shapes. For example, to calculate the area of this shape, we could split it into rectangles like this, but we do not have the length of rectangle B. We can use the other measurements to work out that the length is 8 centimetres plus 4 centimetres plus 6 centimetres, which equals 18 centimetres. We can then calculate the area in the usual way. The area of rectangle A is 8 multiplied by 6, which is 48 centimetres squared. The area of rectangle B is 18 multiplied by 5, which is 90 centimetres squared. The area of the compound shape is 48 add 90, which equals 138 centimetres squared. Pause here to calculate the area of this compound shape. You might need to work out a missing measurement first. You could have divided the shape in different ways. Here are 2 ways that you could have used. Which one did you use? Well done if you got the right answer. Now it's time for a final challenge. How would you calculate the area of this shape? Think of it as if the smaller white rectangle has been removed from the larger green rectangle. Pause here and have a go. If we label the green rectangle as A and the white rectangle as B, we can calculate the area of both and then subtract the area of B from the area of A to find the area of the shape. The area of A is 120 centimetres squared and the area of B is 35 centimetres squared. The area of the shape is 120 subtract 35, which is 85 centimetres squared. I hope this video helped you understand how to calculate the area of compound shapes. If you're looking for more maths help, then we've got lots more of these videos on the Twinkl website, so why not go and take a look? Hi, this video is here to help you with shapes that have the same area. Before we get started, let's recap some shape vocabulary. The perimeter of a shape is a distance around the outside of the shape. It is measured using units of length, such as centimetres and metres. The area of a shape is the amount of space inside the shape. Area is measured in squared units of length, such as centimetres squared and metres squared. One way of calculating area is by counting squares. We can work out the area of all of these shapes by counting the amount of squares inside them. When counting squares, you should mark off each one as you count them like this. The green shape has an area of 10 centimetres squared. What do you notice about all of these shapes? That's right, they all have the same area of 10 centimetres squared. This shows us that shapes with the same area do not have to look the same. Which of these shapes have the same area? The green, yellow and purple shape all had the same area of 16 centimetres squared. We can also calculate the area of a rectangle by using the formula area equals length times width. The area of the green rectangle is 6 times 4, which is 24 centimetres squared. Which of these rectangles have the same area as the green rectangle? There were 3 more rectangles with an area of 24 centimetres squared. Well done if you spotted them. Let's look again at the lengths and the widths of the rectangles with the same area by putting them together in a table. We can see that the measurements of the rectangles with an area of 24 centimetres squared were all factor pairs of 24, numbers that multiply together to make 24. If you need more help with factors, there is a What Are Factors video on the Twinkl website which goes through this in more detail. We can use this relationship to find other sets of rectangles with the same area. For example, to find which size rectangles have an area of 20 centimetres squared, we can list the factor pairs of 20 like this. This shows us all of the rectangles that have a length and width which are both whole numbers with an area of 20 centimetres squared. Can you use this method to find the measurements of all the rectangles that have an area of 30 centimetres squared? Pause here and have a go, and remember to use factor pairs to make sure you find all the possibilities. There are 4 rectangles that have a length and width which are both whole numbers with an area of 30 centimetres squared. Well done if you found them all. Now it's time for a challenge. Is this statement always, sometimes, or never true? If shape A has a greater perimeter than shape B, it also has a greater area. Find examples to explain your answer, and you might also find it useful to use squared paper. This statement is sometimes true. Here is an example where it isn't true. And here is an example where it is true. I hope this video helped you understand shapes with the same area. If you're looking for more maths help, then we've got lots more of these videos on the Twinkl website, so why not go and check them out?